Hi everybody, my name is Adam. This is the official SAT practice test number 10. It is section 3 of that test, the no calculator math section. And as I have noted up here, it is the actual October 2018 SAT test. So it's a pretty recent one. Great way to get started studying. So I'll try to make it a good video for you. Let's go ahead and jump in. Problem 1, they want what value of z satisfies the equation above. So what they're asking for is satisfies the equation means solve for z. So take your equation. They list up here, subtract z from both sides. Will leave you with just z, 2z minus z, just z, plus 1 is equal to 0. Subtract the 1 from both sides, leaving you with z is equal to negative 1, and that's the answer as B. Problem 2, a television with a price of $300 is to be purchased with an initial payment of $60 and weekly payments of $30. Which of the following equations can be used to find the number of weekly payments W required to complete the purchase, assuming there are no taxes or fees? Okay, you can take a look at the form that all these equations take, and notice that they're pretty much in the line form, where y is the 300, so the value at the end point when you've paid back that full $300, with the slope and initial conditions here, and you can notice that most of the differences are in these initial conditions. You can take a look, what is our initial condition? Our intercept, go back to the initial problem, initial payment of $60. So you know that 60 is going to have to show up in the final equation. It's what you started your payback with before even worrying about W weeks. It's the initial payment. So you know 60 will have to show up in the final solution. So B can be eliminated, D can be eliminated. Next, you think about y is taking the form of 300. So it's positive 300 when you're finished. So you know that to get to 300, your initial was a payment towards that. So it's also positive. So that $60 is a positive number, and you can then conclude that C is your correct answer. To finish out thinking about that problem, you can think about 30W, which shows up in both A and C, so you don't have to worry about too much about it. But 30 is the $30 you're paying every week W, so 30 is the slope of that payback line. Again, it doesn't matter. You can go ahead and conclude C right when you figured out that initial intercept. Problem 3, they start with getting this table of shipping charges and a bunch of different weights and the shipping charges associated with those weights. They say that table is an online realtor, sporting goods. You won't need any of that. There's a linear relationship between the shipping charge and the weight of the merchandise. Okay, so that's important. Linear relationship means that this is all aligned, so you can probably throw out most of this data because it's just representing a line. They're going to be asking about, looks like they're asking about a line form down here. Which function can be used to determine the total shipping charge, f of x, in dollars, for an order with merchandise weight X pounds. Okay, so start by looking at the forms that your final equations take. It's the y equals mx plus b form of a line, m being the slope, b being the intercept. And looks like there's a pretty quick way to get this one done, which is take a look at, again, I said this is linear, so just throw out these last two lines. They're larger numbers. We don't want to deal with larger numbers. Just look at these two. So you can see that you know y equals mx plus b. B would be the initial charge. So the charge that you're going to pay regardless of what the weight is. If you ship 0 pounds, there's going to be some charge. And you can see that 10 pounds is $21.89, 5 pounds is $16.94. So 0 pounds is not $0. There's some B term. So right then and there, you can throw out A and you can throw out C because the intercept is not 0. There will be some intercept. Then you can look and say, okay, well, the intercept, it's linear. And the intercept is not $16.94 because that's what you're paying for 5 pounds. That's the intercept plus some amount that you're already paying. So this $16.94 cannot be the answer, which leaves you only with B as your correct answer. And if you wanted to take that a step further, you could go ahead and set up the equation of a line. You could do rise over run with the weights and the shipping charge, but it's unnecessary in this case. You've eliminated what you need. You can go ahead and circle B as your answer. Okay, problem 4. The line in the xy plane above represents the relationship between height, h of x. So right here is height. Just put that as h in feet. And the base diameter, x in feet. So we'll go ahead and call this base diameter. We'll just call it b. For cylindrical Doric columns in ancient Greek I guarantee you will not need that information. Greek architecture. How much greater is the height of a Doric column that has a base diameter of 5 feet greater than the height of a Doric column? Wow, they said Doric 3 times in a math problem. Doric column that has a base diameter of 2 feet. So what they're asking for here is to use your x on the graph at 5 feet and 2 feet. figure out what the h of x is at that point, so what the height is at that point, and then subtract the two. So they're asking for, with a base diameter of 5 feet. Another point I should make here is that when they say, anytime you see the word diameter in an SAT problem, make sure they're not like giving you radius and asking you to convert diameter. They love to do that. In this case, it's all in terms of diameter, so you're okay. Just make sure they don't like give you a radius and you have to multiply by 2. But in this case, you can just go right ahead. So they have, back to the problem, they have the base diameter of 5 feet, which you can see equates to a height of 35 feet. 35 feet, and then they're asking for how much greater is it than when it has a base diameter of 2, and you can take that up to see that with a base diameter of 2, it has a height of 14 feet. So that means that how much greater means subtract, and that is equal to 21 feet greater, and that is answer C. Problem number 5, if x is greater than 0, which of the following is equivalent to the given expression? The expression is here. It looks like the key to this problem is understanding that for a square root like this, you can pull out the terms, and a square root, everything under a square root that's all multiplied together, you can do it as a square root times a square root, meaning you can do square root of 9 times square root of x squared, which will give you square root of 9. All the small numbers squares you should have memorized, so this will be square root of 9 is 3 times square root of x squared is just x, which means that the answer is A. And if you didn't remember that whole thing about, you can pull out the square roots and, multiply them together, you can also look at this and look at the other answers you have. You have an x squared in your original expression, and that's under a square root. So you know that you'll be left with x in the end, so you can go ahead and eliminate b and eliminate d right off the bat. And you have a square root of 9 in there too, and there's no way that constant's going to get bigger, so it's not going to be 18. You can eliminate c, which will also get you to answer A. Problem number 6, they're asking what are all the values of x that satisfy the equation above. So basically solve for x in this expression, and they give you 4 choices here, one of which is 2 choices. So I'll start with how I would probably solve this problem, then go into the way they want you to solve the problem. So they only give you these choices here. All the numbers are small. It's pretty easy to just plug these in and see what works. And the first one, well, we'll start with C. We'll start with C because 1 is pretty easy to see doesn't work, because that'll make your denominator 0. It'll make this a non-rational function. You can go ahead and eliminate C. That's not going to work for x. 0 is also pretty easy to plug in because that just makes the x's go away. You'll have -1 over -1, which will just be 1. Obviously not equal to -2, which just leaves you with -3. So you already know that -3 has to be there, so don't even bother calculating it. Just go ahead and calculate -1 to see if it's A or D. So you plug -1 in here, that'll give you -2. Plug -1 in here, it'll give you +1. That'll give you 0. 0 is not equal to -2, so -1 is not. So D you can throw out. So the answer has to be A. Only -3 is a solution. Now the way they want you to do this, which I think is a little bit slower, but it's probably the way that they are intending, is you can, if you recognize that the top, the numerator, is equal to x plus 1, x minus 1, divided by x minus 1 is equal to -2, you can go ahead and cross out that x minus 1, which will give you x plus 1 is equal to -2. Subtract 1 from both sides gives you x equal to -3. Which of those you find faster? I find the first way faster because a lot of that you can do in your head, but this way gets you there too. The answer is A. Problem 7, the graph y is equal to f of x, just a function on the xy plane. What is the value of f of 0? So what they're asking for is just plug 0 in for x, which means when x is equal to 0, what is the value of f of x? Just what is the value of y on the y-axis? 4. Correct answer is D, 4. Problem 8, in the figure above, point B lies on AD. Lies on this line. What is the value of 3x? They give, okay, so they have these 3, and because this is a 90-degree angle, you know that these 3 must add up to 90. So you can go ahead and make yourself an equation there. You can do 90 is equal to x plus 2x plus 2x. That means that 90, just simplify that, is equal to 5x. Divide both sides by 5. That gives you x is equal to 90 divided by 5, 18. That means that x equal to 18, remember, go back to the problem. What are they asking for? They're asking for 3x. They even put 18 there as an answer to try to confuse you. Don't fall for it. You need to multiply that by 3, so that means that 3x is equal to 18 times 3, so 15 times 3 plus 3 times 3 will give you 54. 3x is equal to 54, and that is answer C. Go ahead and bubble that one in. Okay, problem 9, they're looking for which of the following is an equation of the line in the xy plane above. The tricky thing about this problem, all the solutions they give are not in clean y equals mx plus b form, but you can probably tell that you can get the y equals mx plus b rearranged to get in this form. So let's find, y is equal to mx plus b, where b is the intercept. Pretty easy to see on this graph. They even show it. The intercept with the y-axis is -4, so b will be -4. M is the slope, which is rise over run. So you can go ahead and draw it out for yourself. If it's easy, just go through the intercept. It is in this case. So you have a run of 4, rise over run, and a rise of -4. So that is equal to -1. So writing that out, y is equal to negative x minus 4. Just add x to, it's pretty easy to see at this point. You can put this into one of the forms we're looking for over here. Just go ahead and put this into y, add x to both sides, plus x equal to -4. See if you have that as a solution. Well, it's x plus y, but it is there as C. X plus y is equal to -4. Problem 10, the graph of y is equal to 2x squared plus 10x plus 12, a parabola, is shown above. If the graph crosses the y-axis at point 0, k, what is the value of k? All right, so they're just asking you to, if x is equal to 0, then what is y at that point? And this is a problem where they're really trying to confuse you by giving you a parabola and just trying to make that, the graph really adds more confusion than it adds. Just ignore the graph entirely and just know that what they're asking you for is for x is equal to 0, what is y? So you can go ahead and plug that in. 2x, that becomes 0, that becomes 0. It's simply y is equal to 12, which you have as D. Problem 11, a circle in the xy plane. They give you the center point of 5, 7 and a radius of 2. And which of the following is the equation of the circle? Okay, in the SAT world, there's very little you have to memorize. The equation of the circle is one of them. I'll probably do a video on this later. But that equation, if you don't know off the top of your head, is x minus h squared plus y minus k squared is equal to radius squared. In this case, 5 is your h, 7 is your k, and 2 is your radius. So you have to go ahead and square it, which will make that 4. So if you just know that 2 squared, you can go ahead and eliminate these off the bat. And then you have minus, both of them are positive, so -5, -7 is the correct answer. So you have A is your correct answer. Problem 12, they give you a figure with 2 triangles. In the figure above, triangle ABC is similar to triangle DEF. Similar meaning that all the angles are the same. So this angle is the same, and this angle is the same. What is the value of the cosine of E? So they're talking about this angle here, which is the same as this angle here. At this point, what they're testing you on is knowing that cosine of the angle is equal to adjacent over hypotenuse. You may have learned this as SOHCAHTOA, where co is C is equal to A over H. And at this point, this angle is the same as this angle, so you have adjacent of 12 over hypotenuse of 13, which is answer B. Okay, problem 13. In the xy plane, the graph of the function given here has 2 x-intercepts. What is the distance between the x-intercepts? All right, because they tell you it has 2 x-intercepts, it signals that you'll be factoring this function. And because they tell you x-intercepts, that you can go ahead and set f of x equal to 0 for that factored function. So go ahead and write out, substitute in 0 for f of x, and then you know your factored function will take this form here. Because you have an x squared as your first term, you know that the first terms in each of these will be x. X times x is x squared. and then you'll need to have numbers here that multiply together equal 4. So your options are 2 and 2 or 4 and 1, and which either option needs to add up to 5 when summed together. So 2 and 2 equals 4, not correct. 4 and 1 sum up to 5, so you know that you'll be dealing with positive 4, positive 1, because they're both positive. It doesn't matter which you put where. You go ahead and solve that. This will be x plus 1 is equal to 0, and also x plus 4 is equal to 0. That means that x can be equal to either -1 or -4. At this point, it seems like you solved it. You have to go back to what the question is asking for. What is the distance between these x-intercepts? And you can think about this as these on a number line. So if you call this your x, you have -1, -2, -3, -4. Distance is 1, 2, 3. Your correct answer is C, 3. Problem 14, they give you an equation up front and ask what are all the values of x that satisfy the given equation, and they give you two options, 1 or 2, and they ask what combination of these options is correct. And this one, there's work you can do on this equation, squaring both sides, things like that, but they only give you two numbers here. This one just screams to be just plug in and see which ones work. So you can go ahead and square root of 4 times 1. So we're trying option 1 here right now. Square root of 4 times 1 is equal to 1 minus 3. That'll be square root of 4 is equal to -2. That'll be 2 equal to -2. It is not. 1 is not an answer. So we know it's not 1 only. We know it's not 1 or 2. Your only options are B or D. So it's just a question of whether 2 works or not. So you can do square root of 4 times 9 is equal to 9 minus 3. So this will be square root of 36 is equal to 6. And that is correct. The square root of 36 is 6, so 6 is equal to 6. Yes, it is. 9 is a correct answer, which means that your answer in the final is B. 2 is correct, but 1 is not correct. You can cross out D. B is correct. Okay, problem 15. In the system of equations above, A is a constant. For which the following values of A does the system have no solution? And when you look at the equations they give you in the system of equations, what they're looking for you to recognize is both of these are linear equations. So where does two linear equations that are a system of equations have no solution? And that occurs when the two lines don't cross, right? The solution is where those lines cross. So if you think about it, you have a few different, here's a normal system of equations. So here's your axis. Let's say you have a line here and a line there. The solution is right there, right? The only time that two lines would not have a solution is when those lines run parallel to one another. So when their slopes are equal, those two lines will never cross, and you have no solution. So what you need to find then is where you can set A such that the slope of both equations is equal. And the first way to do that is to recognize that because these are equations of lines, they can be rewritten in y is equal to mx plus b form. And then you can set the slopes m equal to one another, solve for when they are equal to one another. That will be your A that gives no solution to the system of equations. Okay, so let's rearrange this first one. This one makes it easy for you. Y is equal to, just add 3x to both sides, 3x plus 6. Go ahead and take your second one. Rearrange this in y equals mx plus b form, so you'll have 2y is equal to negative ax plus 4. Divide by 2, you'll have y is equal to negative a divided by 2x plus 2. Remember, all you care about is that the slopes are equal. You don't care at all about the intercept, so just take that this slope is equal to this slope. So now you have when is 3 equal to negative a divided by 2, looks like a 9, negative a divided by 2, multiply both sides by 2, you'll have 6 is equal to negative a, which means that a is equal to negative 6 when those slopes are equal. So that's what they're asking for. When is no solution? When are the slopes equal? Your answer is A, -6. Problem 16, they give you an equation up front and say a manufacturer ships unit of a certain product to 2 locations. The equation above shows the total shipping cost in T in dollars for shipping C units to the closer location and F units to the further location. All right, and then if the total shipping costs were $47,000, so they give you T, 47,000, and 3,000 units were shipped to the further location, so that's F is 3,000. How many units were shipped for the closer location? That's C. So they're basically looking to solve this equation for C. So go ahead, plug the numbers they give you into this equation. It's the no calculator section, but you have to fill in the answers. So usually in this case, the numbers will sort of fall out. You could solve for C first, then plug in numbers. It's probably easier just plug in numbers and see how the numbers work out for you. So let's plug it in. You'll have 47,000 is equal to 5C plus 12 times 3,000 47,000 5C plus 12 times 3, 36. You have 36,000. 47,000 minus 36,000, you'll be left with 11,000 is equal to 5C. Divide both sides by 5. 11,000 divided by 5, you can think of it 10,000 divided by 5. 10,000 divided by 5 is 2,000, and then 1,000 divided by 5 is 200. So add those together, we'll leave you with 2,200. And that is your answer. You can bubble in 2,200 as the correct solution. Problem 17, they lead off by giving you an equation, and they ask if A and B are solutions to the equation above. So they mean if A and B are subbed in for X, what is the value of the absolute value of A minus B? Okay, so they're telling you there's 2 different solutions, which makes sense because it's an absolute value. You can have a positive or negative resulting from that absolute value. So the first solution would be just if the absolute value were positive to begin with, it would look like that. You just replace the absolute value with parentheses. You can go ahead and solve this for X. It will be subtract 1 from both sides of 2x is equal to 4, divide everything by 2, x is equal to 2, and we'll call that first solution A. So A is equal to 2. There's one solution. Now let's solve for B. Because it's an absolute value, it could be that if the whole thing turned out negative, you would multiply by -1 to make it positive. So you'll have that 2x plus 1 is equal to 5. Go ahead and multiply that -1 through. We'll give you -2x minus 1 is equal to 5. Add 1 to both sides. -2x is equal to 6. Divide both sides by -2. X is equal to -3, and we'll call that B is equal to -3. Now go back to what the problem's asking for is the absolute value of A minus B. So we have absolute value of A. We solve for 2. Minus B will be minus -3. That's our absolute value. So you have 2 minus -3. That'll be absolute value 5. It's already positive. Your answer is 5. So you can go ahead and bubble in 5. Okay, problem 18. Juan purchased an antique that had a value of $200 at the time of purchase. Each year, the value of the antique is estimated to increase 10% over its value the previous year. The estimated value of the antique in dollars 2 years after the purchase can be represented by the expression 200A, where A is in a constant. And what is that value of A? Okay, there's a lot in that problem. Okay, so start by thinking about what would the value be after 1 year. That's a little easier to bite off than 2 years right off the bat. So you can start with the initial value is 200. And the multiple, think about if it didn't increase at all, the multiple of this would be 1. If the value doubled, the multiple would be 2. So from that logic, you can think, okay, a 10% increase, you'd multiply by 1.1, right? The 0.1 being the 10% that it gained. And you can do this, that's the first year. For the second year, it also gained that additional 1.1 multiple. So you have another 1.1 for that second year. And this will get you to that 2 years, what's the value after 2 years? And at this point, you can see they're saying the expression is 200a, where a in this case is equal to this part right here. And they're asking for the value of a. So all I have to do is set a equal to that 1.1 times 1.1. And because this is a non-calculator section, they're also testing your ability to multiply decimals. I'll go through it for anyone who might be rusty. You have 1.1 times 1.1. You have 1 times 1, so that'll be 11. And then you're moving on to the tens place. You once again have 1 times 1. You add those together. Give you 1, 2, 1. You have 2 decimal places. You have 1 decimal place there, 1 decimal place there, which means you put your decimal place in 2 places, which means that A is equal to 1.21. Go ahead and bubble in that answer. Problem 19, based on the system of equations above, what is the value of 5x plus 5y? And what they're looking for you to recognize is some of the arithmetic you can do on systems of equation, which means you can just take these two equations and add them together and add each like term together. And for this one, they make it really easy for you because 2x plus 3x is equal to 5x plus 3y plus 2y is equal to 5y is equal to 2,500. And what they're asking for is the value of 5x plus 5y, so you can go ahead and bubble in 2,500. Final problem in the non-calculator section, problem 20. If u plus t is equal to 5 and u minus t is equal to 2, I'm giving you a system of equations, what is the value of u minus t times u squared minus t squared? Okay, the form that they've given you for this u plus t and u minus t should be a tip-off that this can probably be factored to be in those terms, so that all you're left with is terms of u plus t and u minus t. And you already have the first term, u minus t, you already have that as equal to 2. So you just have to look at this second one and think, can it be factored down to make this easier to plug in? And think about how to factor this. Your first term is u, which means that the first term of both of these is just going to be u, and u squared, and the last term is t squared, so you know these will be t. There's no u times t shows up in the middle, which means that these have to add up to 0, so that means that you'll have 1 minus and 1 plus. You can go ahead and plug in. Now everything is in terms of u plus t or u minus t. So you can go ahead and plug those back in. You have u minus t is equal to 2 times u minus t is equal to 2, and then u plus t is equal to 5. So I'll give you 2 times 2 is 4 times 5 will give you 20, and you can go ahead and bubble that in and be done with the non-calculator section.